Hello, I'm John Fletcher, Co-Director at Petrolab. Here I'm undertaking a Stage 1 concrete screening test, which involves looking at perhaps a dozen samples of concrete brought in by the chartered surveyor from the property that's being tested. Basically, we look to identify the aggregate that the concrete is made from, and we use our eyes and the stereoscopic microscope to examine the core or cut samples after they've been washed and to record the aggregates that we find. Over 80% of the aggregates that we find are what we call Group 1 aggregates, and they're considered stable, and the concrete's usually found to be sound, and that's as far as the testing goes. In a small proportion of the samples that we do look at, we do find mine waste aggregates, and to confirm the class of the concrete, we then have to do a further stage of testing, which involves making a thin section of the sample and looking at it in more detail under the petrographic microscope.
Lab where we make our Mundic thin sections using this machine. We start off with a core like this. We cut them here and then grind them on this side after they've been mounted on a glass. So we end up with a chip that looks like that. And eventually we end up with the finished thin section, which looks like this.
Hi, I'm James Strong, I'm one of the directors at Petrolab, and in this lab we conduct this Stage 2 examination of concrete. If a concrete at Stage 1 has remained unclassified, it is then prepared into a thin section in our thin section lab and examined under the petrographic microscope. Under this examination we determine the composition of the aggregates, determining the percentage of mine waste in the sample. We also look at the condition of the concrete, looking for evidence of aggregate-related degradation, sulphate attack, leaching, potentially by prolonged exposure to either groundwater or surface water percolating into the concrete. This examination is conducted primarily on the petrographic microscope, but also on the stereoscopic microscope, where we look at a slice of concrete to determine the condition of the sulfides in the sample and looking for evidence of macroscopic fracturing. The composition of the aggregates is determined either by visual estimation or by using a mechanical stage such as this to calculate the aggregate, the percentage of the aggregates that are in the concrete. After this testing has been conducted, the concrete is then classified. If the concrete contains only a small amount of potentially deleterious mine waste and there's no evidence of significant aggregate-related degradation, it may be reclassified as an AB concrete. If the concrete contains a significant proportion of mine waste and shows no evidence, but however shows no evidence of significant aggregate-related degradation or evidence of sulphate attack, it may be classified as a Class B concrete. If the sample shows, or the concrete shows, evidence of significant aggregate-related degradation or evidence of significant sulphate attack or leaching, it must be classified as a Class C material.